Betelgeuse, the red giant star positioned on the very edge of our galaxy, is currently transmitting ominous signals across the vast expanse of the universe. Through the powerful lens of the James Webb Space Telescope, astronomers have now uncovered something profoundly unsettling about this colossal celestial body. As the renowned astrophysicist Brian Cox issues a grave warning, a critical question looms large. Are we standing on the precipice of witnessing a catastrophic supernova explosion? An event with the power to forever change the night sky as we have always known it. Let's dive in and explore this cosmic mystery. Within the grand and intricate tapestry of the cosmos, a place where stars are continuously born, live out their lives, and die in the most spectacular fashion, one particular star has recently captured the combined imagination and concern of both professional astronomers and the general public alike. This star is the remarkable Betelgeuse, a red supergiant of truly immense proportions and great age, situated very conspicuously within the famous constellation of Orion. Its distinctive reddish hue and famously variable brightness have long been a source of scientific intrigue, but a series of recent dramatic developments have significantly intensified global interest in this particular celestial giant. As we continue to explore the very nature of Betelgeuse, we increasingly find ourselves standing on the cusp of a potentially monumental event within the life cycle of this aging star. But what, precisely, could these significant changes in Betelgeuse actually signify for its future? Are we right now witnessing the prelude to a cosmic spectacle of an almost unimaginable scale? Betelgeuse, measuring approximately 764 times larger than our own Sun, is nothing short of a stellar behemoth. Its truly colossal size is almost beyond the scope of human comprehension. One must imagine a star so incredibly vast that were it to suddenly replace our Sun at the center of our solar system, its searing surface would extend far beyond the orbit of Mars, thereby completely engulfing the inner planets of Mercury, Venus, Earth, and Mars in its fiery stellar embrace. This incredible size is not merely a testament to Betelgeuse's immense physical attributes, but also eloquently speaks to its current, advanced stage in the standard stellar life cycle. As a red supergiant, Betelgeuse is now in the final twilight of its existence, a specific phase characterized by extreme expansion and subsequent cooling, which follows a long life spent furiously fusing hydrogen into helium within its incredibly dense core. But what about the specific age of this ancient star? Betelgeuse, believed to be around 8 to 8.5 million years old, is considered relatively young when measured in the abstract terms of the universe, but it is undeniably ancient within the specific context of stellar lifetimes. Its current phase as a red supergiant is the direct culmination of many millions of years of complex stellar evolution, a period distinctly marked by a series of dramatic changes and powerful internal processes that have fundamentally transformed it from a hot blue youthful star into the cool red giant we observe in our sky today. The complete life cycle of massive stars like Betelgeuse is essentially a grand story of constant transformation, a narrative driven relentlessly by the opposing forces of nuclear fusion and immense gravity. Betelgeuse's distinctive and captivating reddish hue is another definitive hallmark of its current evolutionary stage. This striking red color is a direct result of its relatively cooler surface temperature when compared to other hotter stars like our own Sun. While the Sun's surface temperature burns at about 5,500 Kelvin, Betelgeuse's much cooler surface registers temperatures around only 3,500 Kelvin. This significantly lower temperature allows Betelgeuse to emit light predominantly at longer wavelengths, which gives it its characteristic red appearance to observers on Earth. But this iconic color is not just a simple visual trait. It provides critical clues about the star's current physical condition and the complex processes occurring deep within its vast, gaseous expanse. Adding even further to Betelgeuse's enduring mystique is its documented historical color change. Some ancient Roman and Chinese astronomical writings suggest that around 2,000 years ago, Betelgeuse appeared more yellow than red. It was only later in the 9th century that Arabic scholars provided the first descriptions of it as a distinctly red star. This observed color shift over recorded human history is not just a minor detail in the ancient annals of astronomy, but serves as a vital clue to the star's own evolutionary path, indicating a gradual cooling of its surface over the centuries. The famously variable brightness of Betelgeuse is yet another intriguing aspect of its behavior. It is officially classified as a semi-regular variable star, which means its observed light output periodically waxes and wanes in a somewhat predictable pattern, and this inherent variability is a characteristic dance of luminosity that has fascinated astronomers and amateur skywatchers for centuries. Typically, Betelgeuse undergoes a primary brightness cycle that lasts about 400 days, along with a secondary longer cycle that stretches approximately 5 years. These distinct cycles have been carefully documented as far back as 1836 by the astronomer Sir John Herschel, and possibly even earlier within rich Aboriginal oral traditions. But what makes Betelgeuse truly enigmatic is not just its routine-changing brightness, but its occasional stark irregularity. Unlike many variable stars that follow a highly predictable pattern, Betelgeuse sometimes dramatically deviates from its rhythmic dimming and brightening, strongly hinting at complex and less understood internal processes occurring within its colossal form. In a recent and truly groundbreaking revelation, Betelgeuse once again captured the full attention of astronomers and stargazers worldwide with an entirely unexpected and deeply dramatic change in its familiar appearance, an event now famously known as the Great Dimming. In late 2019, the red supergiant Betelgeuse, one of the brightest and most recognizable stars in the entire night sky and a prominent feature of the Orion constellation, began to mysteriously and rapidly dim. The star's dimming was so pronounced that it began losing its characteristic luminosity at an average rate of 0.01 magnitudes per day, ultimately reaching its absolute lowest brightness in February of 2020. Betelgeuse, which is normally easily visible to the naked eye, even in heavily light-pole urban areas, became markedly fainter, a dramatic change that was noticeable even to casual amateur observers. However, there exists one fundamental problem with our attempts to accurately monitor the activities of a distant star like Betelgeuse: the inescapable time paradox. When we look at a star like Betelgeuse, we are not seeing it as it exists in the present moment, but rather as it was in the distant past due to the finite time it takes for its light to travel across space to us. In Betelgeuse's specific case, at approximately 725 light-years away from Earth, the light we perceive today actually left the star's surface nearly 7 centuries ago. This significant time lag makes it profoundly challenging to predict and monitor any sudden changes in a star's behavior in real time, as we are essentially always peering into its historical past. The Betelgeuse dimming event served as a stark reminder of the inherent difficulties involved in real-time astronomical observations and the serious limitations of our understanding when dealing with the vast scales of the cosmos and the time paradox they inevitably introduce. The unfolding of Betelgeuse's celestial drama was closely monitored by Andrea Dupre, the Associate Director of the Center for Astrophysics at Harvard and Smithsonian, and her dedicated team of researchers. They utilized the Hubble Space Telescope to meticulously analyze the behemoth star, as part of an ongoing 3-year study designed to monitor variations in Betelgeuse's complex outer atmosphere. These detailed observations offered a unique and invaluable insight into the dynamic mechanics of a variable star like Betelgeuse, which regularly expands and contracts, thereby causing observable fluctuations in its overall brightness. Hubble's exceptional sensitivity to ultraviolet light allowed the researchers to effectively probe the mysterious layers above the star's visible surface, layers which were being heated partly by the star's own turbulent convection cells. Further in-depth analysis of the Hubble spectra, which were taken at different points throughout 2019 and 2020, greatly helped in measuring the precise movement of material within Betelgeuse's outer atmosphere. In particular, the spectra were focused on specific magnesium-2 lines, which are highly indicative of the star's current atmospheric conditions. These crucial observations clearly showed material moving at astonishing speeds of about 200,000 miles per hour, flowing from the star's surface out into its extended outer atmosphere, This super-hot, incredibly dense material eventually extended millions of miles from Betelgeuse and was identified as the direct precursor to the vast dust cloud that ultimately led to the star's dramatic dimming event. Dupree and her team estimated that about twice the normal amount of material from Betelgeuse's southern hemisphere was lost over the 3 months of this massive outburst. This tremendous mass loss was significant, especially when considering that Betelgeuse, like all stars, does continuously lose mass, albeit at a rate far greater than that of our modest Sun.